Okay, this is part 2 of quadratic extensions, looking at 3 different problems here. For each of the quadratic functions, you're going to state the y-intercept, the x-intercepts, there might be more than one. There actually can only be at most 2, okay, x-intercepts. The vertex and the equation of the axis of symmetry. And actually, in a way, the equation of the axis of symmetry comes before the vertex because you have to find the axis of symmetry in order to find the vertex. Okay, so the very first thing you're going to notice here is this starts with a negative. If we just start to look, you know, one thing that you can actually explore a little bit on your calculator is just that basic quadratic pattern. If I were to graph x squared and then I were to graph negative, now when I use negative, make sure you use the negative button, not the subtract button. Okay, so negative x squared. These are just 2 basic quadratics here. Okay, we call these in a lot of your upper level math classes, you might call this the parent function. And what you might be able to see now, although it's not coming out very crisp and clear, I think, on the video, is that one of the parabolas opens upward while the other one opens downward. So that leading coefficient of x is going to tell us if the parabola is going to smile or frown, right? Positive x squared, it's going to be positive. Negative x squared is going to be negative. If you go to the table of values, you're going to see the basic shape, the basic numbers of the parabola. You see how it takes 1 and squares it and gets 1, 2 squares it gets 4, 3 squares it gets 9, 4 squares it gets 16. The y values then are all perfect squares, right? So this is what we call the parent function. The basic parabola y equals x squared. If we did a table, it would be x, y. We plug in various, this is exactly what we did in Math 60 to graph a line. 1, -1, -2, -3, +1, +2, +3. This is creating a table of values. What happens if I square -3? I get 9. If I square -2, I get. If I square -1, I get. If I square 0, I get. If I square 1, I get. Square 2, and 9. So you can see that symmetry is happening, okay? If I plot the points, 0, over 1, up 1, over 2, up 4, over 3, up 9, over 1, up 1, over 2, up 4, over -3, up +9. So this is the basic shape of all quadratics, is called a parabola. Okay, this shape. Now, if I were to make it y equals -x squared, what would happen is it would take all of these values, and because I'm not squaring the negative, it literally looks like this. If I plug in 1, I get y, or if I plug in -2, let's say, I will get -2 squared. What is that? It's actually -4 because you would square the negative, giving you a positive, then you would be making it negative. So you would get the exact same values, -3, -2, -1, 0, 1, 2, 3, 4, let's say, okay? You would get the opposite of those values, -9, -4, -1, -0, just kidding, 1, oops, -1, -4, -9, -16. So you would get the exact same shape, but it would frown because of the negative in front. That's the throwing, a lot of the problems we did that were like throwing the ball. Okay, so the basic premise here is how do we find, what's the rule to finding the y-intercept? Y-intercept happens when x equals 0, okay? The x-intercepts happen when y equals 0. And then the vertex, so here is x equals 0 for the y-intercept. And this would be something you could put in your notes, right? And give yourself a few examples. How do I find the vertex and the equation of the axis of symmetry? over 2a. Over 2a. So you will want to memorize this, or again, put it in your notes, okay? And then the vertex is literally you're going to plug that in. Negative b over 2a is the x value. And then f of negative b over 2a. This was all stated on the previous page. So who can tell me what is the y-intercept for the first one? 0, 5. Because remember it says in xy forms. That means as an ordered pair. How do I find the y-intercepts? 0 equals negative x squared minus 4x plus 5. I need to solve this in order to find the x-intercepts. So how do I solve that? Once I set y equal to 0, how am I going to solve it? Solve it by factoring. What should I do first? GCF, what is the GCF? Yeah, I would divide everything by negative 1. And the reason why is because I don't want to factor. Now I'm solving. I can do whatever I want so long as I do the same thing to both sides. I don't want to factor with the leading coefficient being negative. You have never factored something like that. So that's why I said number one rule of factoring, if it starts with the negative, factor out the negative. It's not going to affect your answer because you can do whatever you want when you're solving so long as you do the same thing on both sides. 0 equals, and what are the ordered pairs here? Oh, x plus 5, x minus 1. Someone's getting very good at factoring. So what does that mean your x values are? And 1. So tell me your intercepts, your x-intercepts. Negative 5. Is it together in ordered pair? Together? Ah, and 1, 0. Good. What's the vertex? Yes, x equals negative b over 2a. So tell me what is a in this case and what is b? Negative 1. B is negative 4. So you have to get it from the original equation. Here's a, here's b, here's c. We already used c. That was the y-intercept. Okay, so now we plug it in. b negative, oops, negative 4 over 2 times, okay, we get 4 over negative 2, which is negative 2. Now, that's the x. So this is the axis of symmetry. X equals negative 2 is the axis of symmetry. So whatever the x value is, that's going to cut everything in half. Notice that what would be, if you were thinking about the graph of this, okay, let's just sketch a graph. 0, 5. 1, 2, 3, 4, 5. This is my y-intercept here, okay? My axis of symmetry is x equals negative 2. So over here, 1, 2, 3, 4, 5. Oops, going off the page. Okay, and 1. X equals negative 2 is this whole entire line. Okay? And then your x-intercepts are negative 5 and 1. How many points away is negative 5 from negative 2? And how many points away is 1 from negative 2? Should be 3. 1, 2, 3. Over here. 1, 2, 3. Oh, so the axis of symmetry is happening in the middle, right? Now I know that this line is x equals negative 2. Somewhere on this line is my vertex. How am I going to figure out where on that line the vertex goes? I would plug this x in to the formula. I would find f of negative 2, which would be negative 2 squared minus 4 times negative 2 plus 5. You can punch that into your calculator, or let's figure it out. Negative 4 plus 8 plus 5. Anyone know what that is? 13 minus 4 is 9. Good, 9. So what's the vertex then? Put it together. 2, 9. Negative 2, 9. So we go over to negative 2, up to 9. Let's call it up here. Negative 2, 9 is the vertex. So that means it connects, and over here it connects, and it opens downward. So again, if you want to look at this on your calculator, you can also check these points out on your calculator. So turn the calculator on. That's the first rule. I already showed those two. Maybe we should try and zoom this in. Okay, so we got negative. Remember again, if you're using a negative, to use this little negative sign down here, not the subtract, otherwise you will get an error message. Okay, x squared minus 4x plus 5. Press graph, and we should see this shape here. Now there's lots of different things you can do on the calculator as well, and Desmos, like I said, will work just fine for this. But if we want to find that vertex right here, the top point, you can actually go second, calculate, that calculate menu. On the calculate menu you have value, zeros, minimum, maximum, intersect, okay, and then some other things that we're not going to use in this class. What point is this? When you look at the vertex, how could you describe the vertex? It's a, does it, oh, the highest point, or the maximum. So if I want to find the maximum, I go 4. Left bound means I have to go to the left side of the maximum. Am I on the left of the maximum? Yes, I push enter. Right bound means I need to go scroll over to the right side of the maximum. Am I on the right side of the maximum? Yes. Enter. Now it says guess, and just push enter through that. And you should get, well, there's a little glitch in the calculator, the reason why it says 1.9999997. It's actually 2, or negative 2. Sorry, it says negative. Negative 2, 9. So that's just a little bit of a technology glitch, okay? It really is negative 2. We proved it. We found that answer right there, okay? So you could also go to the table of values, second table, and you want to look for these points. 0, 5 is there. Negative 2, 9 is there. There's negative 5, 0, which we found. And scrolling down, you can see 1, 0 is also there. Okay, so the same rules apply. Basically, there's 3 steps. Find the y-intercept, find the x-intercept, find the axis of symmetry that helps you find the vertex. So let's just try it one more time. Or do you guys want to take a chance? Why don't you guys try it in your groups? You try the next 2, and then we'll do a video summarizing those, since this is